This video is a continuation of the previous one where I showed how to use GitHub Copilot to create a CALM architecture as code file. If you haven't seen that earlier video yet, I recommend watching it first because here we're building directly on top of that work. Before diving into the demo, let me do a quick level set on CALM. CALM, C-A-L-M, stands for Common Architecture Language Model. It's an open source project sponsored by the FinTech Open Source Foundation, and its goal is to provide a standard machine-readable way to describe software architecture. With CALM, architecture isn't just a diagram or a document, it's a structured model that can live alongside your code. This is where the idea of architecture as code comes in. By defining your architecture in a formal language like CALM, you can version it, review it, and evolve it just like you do with source code. That means your code base changes, your architecture definition can change with it, staying accurate instead of slowly drifting out of date. So with that context, let's walk through today's video. Here I'm in VS Code with the CALM architecture file open alongside the latest version of the code base. So here's the CALM architecture as code file. All right. At this point, the architecture file has already been updated to reflect the latest version of the code. What I want to walk you through are the GitHub Copilot prompts I used to do the update. First, here is the prompt that I used to update the file with the latest set of application changes. Okay. So from here, here's the actual prompt that I used, where I say update CALM architecture definition on doc/calm/connection solver .architecture.json to reflect new or change nodes, interfaces, and flows. So this is where now I'm expecting GitHub Copilot to look through the code base, figure out what the latest set of changes are, compare it to what's at that point the CALM architecture document, and implement the delta changes. So here you can see GitHub Copilot is beginning to analyze the CALM architecture definition, and it's reading the project files, looking to see what changed. And you can see here it's doing that. And then at this point, it knows enough where it now says I'll update the CALM architecture JSON file with the changes. And you can see it's now beginning to make small edits to the file to reflect the changes. Okay. All right, and then it's just double check to make sure that the architecture file is still a standard JSON structure. And now it says it's updated the CALM architecture document with the changes, and now it's summarizing what the changes are. In particular, it noted that there was a new change about implementing a database, which is correct. That was the last set of changes I put in, and with the new database, there are a bunch of new relationships and some new flows. So again, at this point, it looks like it detected the latest set of changes and updated the document to reflect that. And this latter part of the conversation is I'm just asking it to validate the CALM architecture definition, and it looked like it found one small issue, and with that it made a correction, and now we have an updated architecture document reflecting the latest set of changes. With that in place, I then decided, well, once the core architecture structure is up to date, the next step is improving the metadata. CALM supports rich metadata, things like ownership, lifecycle state, responsibilities, and descriptive context that makes the architecture more useful to humans and tools. So with this prompt, so now let me show you the prompt that I used to enhance the metadata. Here we go. Okay, so this is the prompt that I asked GitHub Copilot given the updated architecture file, now look at the metadata that's captured in the nodes and interfaces of the docs/calm/connection solver.architecture.json file. Are there other kinds of metadata that should be captured in the architecture document? And now you can see GitHub Copilot, again, reading the file, checking the CALM specifications to see what kind of metadata fields are possible. And based on it, he says that we've currently captured these kinds of metadata, but then it's identified these types of metadata are missing around security compliance, performance SLA, operational concerns, cost resource management, dependencies, data management, testing and quality, ownership, and contract. So it seems like there's a lot of potential metadata that could be added to this, that could be part of the architecture definition that seems to be missing. So now it comes back with some recommendations. So GitHub Copilot says instead of trying to boil the ocean all at once, we can triage the metadata and go in it in a priority sequence. So first it identifies high priority items that should be captured. So these are on authentication, performance, dependency versions, error handling, and service ownership. Then next set are medium priorities around cost, data retention, monitoring, rate limits. Then finally the low priority stuff. All right. So with that in mind, so this is the prompt I now use to ask GitHub Copilot to, from the code base, fill in the high priority gaps. If the information is not in the code base, state unknown. So this is now where I'm now asking GitHub Copilot to look through the code base for the high priority metadata and to fill in those. And this is where it's now beginning to read the code base, find it, and now you can see it's now beginning to make updates to the architecture file to reflect adding the missing metadata. And again, we go through validation port, and it's showing examples of the types of metadata that's being added. Okay. All right. So with that in place, now let me show you after updating the architecture file and enhancing the metadata, let's now look at the updated architecture definition. All right, let me first show you some batch scripts that I used to help me in using the CALM architecture file. So first, we'll look at this one. So this is a file, bash script, that just runs the CALM validate command against the architecture document. So this is my way of being able to ensure that the architecture file is coherent. So let's just do this just to show. All right, so we're just going to validate the architecture file. And you can see that it exists, it's loading it, and it's doing the validation, and it says there are no errors or warnings. Okay, so that's good. So once I know that the architecture file is good, then I use this other script to actually create the artifacts that are used by the viewer. So here we're running the CALM Dockify command to create the artifacts that will be used by the viewer. So let's run this one. And we'll generate the architecture viewer. Okay. Alright, so everything looks like it worked. Okay, so now with that in place, let's let's view the updated architecture document. So let's see. So we'll do this. All right. First, we'll have to install the components that can be used for viewing the architecture artifacts. Okay, so that looks good. And now we'll just start the architecture viewer. Okay, you've noticed that it's launched a Chrome browser. And now we're just waiting for, there we go. The front end to view the architecture has started. So here's the high level view of the architecture. And in particular, the latest set of changes was adding a SQLite database. And here it's recognized that. We can see the SQLite database up here, and that it's picked up the new interfaces to backend for the database, as well as the process flows for that. So here I'm comfortable that the architecture has been updated with the latest set of changes. So now let's look at what are all the things that are possible. All right, so here are all the nodes. So this is the puzzle player, right? Here's the front end web server, web application, and you can see here's the some of the metadata that's been enhanced. Okay, and then for the backend, we have the backend server. Talks about the different interfaces, and with the backend, it's describing each of the endpoints that are here. And then here we go. So this is one of the new endpoints to update data in the database. These are to do endpoints. This is to update the database, and this is to retrieve data from the database. And we can see how the backend is related to other components. And this is the metadata that's been enhanced. All right, so it talks about some of the environment variables that it's looking for, the performance criteria, the errors that are possible, the types of LLM providers that it's able to talk to. Again, these are all metadata that was missing before that is now captured as part of the last set of GitHub Copilot request of enhancing the metadata. All right. And again, in the code base, there was nothing about ownership, so that's why in the prompt I said if it couldn't determine the metadata value, just to say unknown. So it did that. Okay. So these are the nodes. Like I said, these are just the interfaces. But in here we have the different flows. So this is how we set up the puzzle through the CSV file. This is how we get a recommendation for word group. Then given the word group recommendation, this is how the the player indicates to us whether the guess was correct or not. Here we're just validating the access to an LLM provider. This flow is about how we initialize the puzzle from an image. The earlier one about initializing a puzzle was from a file, but this we're able to do from an image of the puzzle. And these two flows again are the latest set of changes. These all deal with updating or accessing the database. Okay, so this is the CALM architecture viewer. While the CALM architecture view is useful, there are some issues in its use. For example, first, some of the images are hard to view, such as the one on the home page. The node representation looks kind of clunky, wide and short, and the text is small, very difficult to read. Second, to look at the entire architecture document, the user has to flip through each item in the left navigation bar. Second, it's not clear to me how I could create a single architecture document with all the content. For example, if I did a print, I only basically get, I'm able to print only the only thing that's being viewed on the web page. It turns out with the CALM architecture JSON file, I can ask GitHub Copilot to create a Markdown document from the JSON file. Let me show the results of working with GitHub Copilot to create a Markdown version of the architecture file. So we'll go to the repo where I've created that Markdown file. And here. So here's a Markdown file that it was created from the CALM JSON architecture file. So as we can scroll through it, you can see, at least from my perspective, the visual representation of the overall system architecture is better. It's certainly easier to read from a text perspective. And we get at various levels of detail. And you can see some of the metadata here. From the back end, we've identified all the endpoints that it supports. Here's the database schema for the database that was recently added. Here's the technology stack, the environment configuration, what are the required environment variables, performance targets, error handling, the deployment model, and now we're getting into the user flows. So this is the one that sets up the puzzle from a CSV file. This is the one that's used to generate a recommendation from the large language models for the group. This is getting a recommendation from the local Olama server. This is the flow where the user is reporting back to the application what was the results of the recommended words, whether they were correct, incorrect, or one-away error. Here, it's checking the connectivity to the OpenAI LLM server. This flow is the flow that allows the human to paste an image of the puzzle, and from that image the assistant can initialize the puzzle. And these last two flows are the recent ones where we've now added a database, and this is the flow for recording the results of a game, and this is the flow for retrieving past game results and showing it to the user on the web UI. Right? So this gives a kind of a high-level summary of the architecture, and it's in a single Markdown document, which, at least from my perspective, we can now do a print, and from here I can print, and it generates 19 pages. So here we can see all of the things, all of the architecture content in a single document, and if need be, I can save it as a PDF file. So this seems like a way I could get a view of the architecture in a more easily digestible format as a Markdown document, and from that I can generate hard copy if need be. All right, to create this Markdown document, let me show you the GitHub Copilot prompts that I used. Alright, so first we'll go back to here and here. So this was the initial prompt. Here I'm saying create a Markdown document called docs diagram connection solver architecture.md containing mermaid diagrams depicting nodes interfaces from the CALM architecture file. And here's the CALM architecture file. This was actually added to the context of the prompt before I asked GitHub Copilot to carry out this prompt. Once that was done, you can see where GitHub Copilot is creating the Markdown file, and it's summarized the things that it did. In reviewing it though, I noticed that one of the flows was missing, so here's an explicit prompt to GitHub Copilot to say this was missing and it should be added to the Markdown document. The flow itself was defined in the JSON file, so from that perspective it was there. It's just that when GitHub Copilot translated the JSON file into the Markdown content, it missed this process flow. So here I asked it to explicitly said, you missed it, please add it. And then one more prompt. And looking, again, reviewing the content of the Markdown file, I noticed that the ER diagram, the entity relationship diagram in the Markdown file was incorrect. So here I'm working with GitHub Copilot to make the correction to the entity relationship diagram. All right. So just to finish up, I'll just want to summarize two things. First, the translation from JSON to Markdown was not perfect. There were some errors and missing information. To address this, I used GitHub Copilot to make the corrections. And just to kind of be explicit about all the things that needed to be changed. So if we go back to So these are the changes I worked with GitHub Copilot to make corrections. We already talked about the entity relationship diagram. Here I made some changes to some of the coloring of the architecture documentation. Turned out there was an error in rendering the process flow. I think that was the one that was missing. And here we're updating the architecture with the some metadata. So again, these kind of reflect corrections that I had to make to the Markdown file because of errors that GitHub Copilot made in translating from JSON to Markdown. So again, I don't want to portray that this is a flawless process, but from my perspective, using GitHub Copilot took all the tedious work of translating the JSON structure into a Markdown structure. And again, once it was in a Markdown structure, it was a much better or easier version to look at. Okay. And maybe one last thing I want to point out is from a metadata perspective, not all the metadata is depicted. If this is needed, then the GitHub Copilot prompts can be modified to be more explicit about the type of content that should be part of the Markdown document. With that, this kind of ends the video about showing how we can show depictions of the CALM architecture document. Let's wrap up with the key takeaways. CALM, the Common Architecture Language Model, is an open source way to represent software architecture as code, not as a static diagrams or tribal knowledge. Because it's architecture as code, it can live right alongside your application source, versioned, reviewed, and analyzed just like everything else. And this is where AI coding assistants really shine. Tools like GitHub Copilot can help keep those architecture artifacts in sync with the real codebase, validate that architecture still reflects reality, and even generate multiple views of the system for different audiences. The big idea is simple. Architecture stops being a one-time document and becomes a living artifact, maintained continuously with AI helping you keep it honest. Please like the video if you found the ideas conveyed useful. Don't forget to subscribe to the channel. Thank you and hope to see you the next time.